All right, everybody, we're back to logarithms, and we got to remember that logarithms really are exponents. So today, we're going to talk about the log, I call it log rules, but it really is the rules that affect the rules that follow exponents. How's that? And we know exponential form, we've got some answer equals b, which is my base to an exponent, can be transformed into the log form, log of base b of the answer equals the exponent. So we know right here that logarithms are exponents. Therefore, if they're exponents, they have to follow exponential rules. We know if we multiply two bases, we have to add their exponents. So we can rewrite this. So if we multiply from logs two bases, we can rewrite this as an addition problem. Okay, so it can be rewritten as log of some base of n plus log of some base times m. So if you multiply two bases, you can add their exponents. Okay, quotient rule. If you divide, we know from exponential rules that if we divide, it's like subtracting exponents. Divide two bases, so we can rewrite this as log of some exponent minus log of some exponent m. Okay? Now, we have seen this before. If you've got the log of the same base, it's pretty obvious. Log of base b of n equals log of base m. So we know that then we can just say that n is equal to m.
You're supposed to find out when your prep period is.
My prep period is fourth period. How come?
It's for flex. Fun.
Okay.
Thank you.
Yes, you're welcome. Now, another rule is the power rule. We know an exponent to an exponent, we just multiply the exponents. Well, that's an exponent, that's an exponent. So we bring down the exponent. We write this as p times the log of m. That's an exponent times an exponent, which seems weird. Okay, now let's use these rules. These rules become really handy in calculus. If you ever take calculus, you're going to need to know these rules. So, example 1. Let's express it in expanded form. Well, you got log base 3 of a times b to the 4th. So I'm going to rewrite this. This times, we're going to separate as a plus. We're going to use this rule right up here. So we're going to use the product rule. We're going to go log base 3 of a plus log base 3 of b to the 4th. Now I'm going to do one more. I'm going to use the power rule right here. And I'm going to float the exponent down. So my grand answer would be log base 3 of a plus. I float the exponent down 4 log base b. Okay? Handy trick for calculus. Okay? When you take calculus. Okay? All right, example 2. Well, I've got a couple of things to do. First thing I think I'll do is just change this to a 1/2 power. Okay? So I'm going to go log base 5 of x cubed over y to the 1/2 power. Okay? Now, what I know is a logarithm is an exponent to an exponent. We're just going to multiply exponents. So we bring down the 1/2 first. Okay? So I'll rewrite this as a 1/2 times all of this, times log base 5 of x cubed over y. Okay? Now, the next thing I'm going to do is separate these. If that's a divide by sign, we look up here, and if we divide logs, we can subtract. So I'm going to go ahead and rewrite this as a subtraction. So I'll rewrite this as a 1/2, because I still have the 1/2. And I'm going to go log base 5 of x cubed minus log base 5 of y. Okay? Now, the last thing I'm going to do is bring this x cubed down, because I've got an exponent to an exponent, so I'm going to apply the power rule. I'll bring this right down here, okay? So I'm going to rewrite this answer as a 1/2 times a 3 log base 5 of x minus a log of y. Okay, that's an expanded form. You're going to need to know this for calculus, okay? Now, example 3 is just the opposite. We're going to take and bring this and rewrite as a single log. So we're going to use these same rules. We're going to do what we did, but just the opposite. So we had something like this, expanded form. We're going to bring it into a nice squished up form. Okay, so we're going to bring it together as a single log. So I'm going to go log up. Well, first of all, let's bring back, this was an exponent that got floated down. Bring the 3 back in. This was an exponent that got floated back. I'll bring it back in. So I brought the exponents down, the power rule was applied, so now I'm going to back up and do the opposite of the power rule and bring it back in. So I'm going to rewrite this as log of a cubed minus log of b to the, bring the exponent back in, 1/2 power, okay? Now, I know that if I'm subtracting, it's the same thing as dividing logs. So I'm going to rewrite this as a single log, log of, and log base 10 obviously, of a cubed divided by log base log of b to the 1/2, but I might change that to square root because we know that a 1/2 power means square root, okay? Okay, on the back side, let's take a look at the back. More log rules, okay? All right, well, if we were to look at the rule, okay, e ln of some value a is just a. So this just becomes x. E to the ln of x becomes x. We can prove that by changing it into log form. Log form be log base e of a equals ln of x. Log base e is ln of a equals ln of x. So we know that the whole thing just equals x, just plain old x. Okay. This is the same way, but before you do that, I'm going to go e. I'm going to bring back in my exponent, okay? Oh, we can't see. Sorry, my bad. Can't see. Bring back in my e, so let's go my exponent. So I'm going to have an ln of x to the negative 2. Those two cancel each other. You got an x to the negative 2 or a 1 over x squared, okay? There's my rule right there, okay? Same thing here, except for this is a little bit different because it's base 10. So same thing, you got 10. And you got log of a just equals a, all right? So before I do anything, I'm going to rewrite this as 10 to the 1 times, and I'll bring this 2 in here, 10 log, 10 to the 1 times a 10 to the log of x squared. This is going to be then a 10. There's my 10 from there, 10 to the 1 times a, that cancels, and I'm just left with an x squared because it follows this rule there. Okay, now, there's another rule that we hopefully read or saw. If we have an ln of e to the a, those cancel and just left with a. I'll prove it. So you got ln of e to the x. We'll set it equal to, say, some value a because that's our answer. Let's change it to exponential form. So we'll change it to log form. So go log base of a equals, wrong way. I want to go change to exponential form, right? So I want to go, no, I just want to float that down. That's just easier. I've got x ln of e equals a. That equals 1. So it's just x. Okay, so it follows the rule. Okay. That should have been a cube root. My bad. Okay, ln of the cube root of x, same thing as ln of x to the 1/3 power, which then I float down the 1/3 ln of x. Okay, and then that's all I can do with that one. This one, the 2x comes down, 2x log of 10, and again, log of 10 is just 1. That becomes 1, so you're just left with 2x, okay? Finally, last but not least, change it in terms of, express y in terms of x. So here's what I want to do. Put these two together. So I'll make that a ln of 1/3, x to the 1/3, because I bring the exponent back in, plus ln of 4. I'm going to combine these with the plus. We write this as ln of 4x to the 1/3. I got ln of y, ln of this. Obviously, the two must be equal. I can cancel the ln's. So So I got y equals a 4x to the 1/3. Okay, that's all I have. I have changed the homework, so I will let you know what the homework is from the substitute. Okay, that's all I got.